Hello guys, welcome back to my channel. So today we'll start about geometric distribution. We have already completed the binomial and Poisson distribution. Today's topic will be introduction to geometric distribution. Okay. So what is geometric distribution? So imagine you're doing the archery, the archery competition or whatever. Now, what will be your highest aim? It will be pointing towards the center of the board, right? That will be your highest aim. But can you do it in the first shot? No, maybe not. But you'll keep trying until you get this this bullseye, right? So this is actually a distribution of geometric because you keep trying until you succeed. That you can take the example of your exams also, or whatever, wherever you can apply this this concept in your real life. You keep trying until you succeed. So let's say you try 10 times, okay? Totally you try 10 times. So out of 10 times, you actually fail, let's say 9 times. According to probability, what is this 9? 9 times you're failing, okay? So which means this is Q. Q is nothing but failure, right? What is success? The 10th time you succeed, which is P, correct? So this is success. So which means totally if you're trying X times, out of that X minus time you fail, and X the time, the final attempt you succeed. So X minus 1 failures and X successes. This is what happening in the geometric distribution. So which means because the independent, this one is the when you shoot an arrow, suppose let's say you're trying 10 times. Every time you're trying the event, every time you try is independent of other events, right? So the first time you try, the probability of that is not affecting the other tries. Let's say the first time you're trying and you're not pointing to the bullseye. Let's say the fifth time you're trying. Are these events connected with each other, or can you tell that these are dependent? No, it's independent, right? So independent events only. Here also that condition holds. Okay, this one should be independent. Okay, all the n number of tries you do should be independent. Now, because the probabilities of everything is independent, you can individually multiply the probabilities, right? That's what we saw in the you remember this Poisson distribution example when I was saying telling P of error, finally not error. So this can be written as P of E into P of E into P of N, right? So what does this mean? This means that, sorry, it's not read properly. So this means that you can individually multiply the probabilities of all the all the individual events, because the events are independent. Here also, when you take an example of archery, every time you try is independent of other tries, which means you can individually multiply the probabilities. So Q is this failure probability. Okay, so Q times you're trying and you're failing. Sorry, X minus 1 times you're trying and you're failing, which means the probability will be Q bar X minus 1. And the final time, which is the X time you succeed, that is P. So which means your PMF will be Q bar X minus 1 into P. That's all. Okay. This simple PMF only. This is what? This is PMF. Okay. So now next we'll see the mean. Okay. Uh, what are the things we generally see in the distribution? One is a condition. We saw the condition. Another is one is the PMF. Now next one is CDF. CDF will see in examples. Okay. And solving examples of geometric distribution. Now what is the mean? What is the formula of mean? E of x is equal to sigma x into f of x. Correct. Which means sigma x into, what is f of x? We saw that it is q power x minus 1 times p. That is f of x, no? So your limits will be, so you cannot try 0 times. Okay, it should be anything above 0. Okay, so your limits will go from 1 to infinity, because you don't know in prior, unlike binomial distribution, how many times you're going to try. In binomial distribution there's finite number n, but here there's no finite number, so which means you'll try infinite times. Okay, so this limit goes to infinity. When you expand this, what will you get? 1 times q power 0 p plus 2 times q power 2 minus 1 is 1 p plus 3 times q power 2, and so on up to infinity. Correct? Can you see what series is this? This is what, see, here you get an AP 1, 2, 3, final up to infinity is this is an AP with a common difference 1. Now this one, if you see, q power 0, q power 1, q power 2 is a GP where your common ratio is q. So both are combined here. So this is an AGP. Okay, if you have studied, sequence and series chapter in class 11th, you, I think you should have studied AGP. It's called arithmetico-geometric progression. Okay, so how will you solve this? There's of course formulas to solve, to directly find this, but we're not going to use formula. Okay, formulas are useless. So when you take S is equal to, take P common. Okay, if you take P common, it will be 1 into q power 0. So it will be 1 into q power 0 plus 2 into q power 1 plus 3 into q square. I think pen is misbehaved. Okay, I don't know. Plus it's on up to infinity. Okay. Now, do one thing. Okay. Now you can multiply this whole series with q. What is the common ratio? Q is the common ratio. No? You can multiply this with q. Okay. If you do multiply with q, you will get p into, I'm just writing for the sake of understanding purpose. I'm writing this: when you multiply q with 1 q power 0, what will you get? You get q power 0 into q, which is q only, right? I'm writing it here. Okay, just for understanding purpose, for easy visualization. Okay, it will be 1 q power 1. Correct. Now next q, when you multiply with 2q, it will be 2q square. Correct. And similarly you get so on up to infinity. Now cleverly you do s minus sq. So which means you subtract these two equations. Okay. When you subtract these two equations, what will you get? Just a second. You get take p common again. P is common outside. Now 1 q power 0 minus, there's nothing here. Okay, just write 1 q power 0. Okay, now plus 2q per 1 minus 1q, which will be what? 2q minus 1q, nothing but 1q per 1. Now 3q square minus 2, you're subtracting. Okay, 3q square minus 2q square, this will be 1q square. This will continue up to infinity. Okay, now what is this actually? Q power 0, q power 1, q square, everything you made, you converted this AP into a single ones, right? So now this is very easy to solve. S minus sq is equal to, p still stays outside. Now this is what? This is infinite GP. Okay, now first we had AGP, we convert that into infinite GP. Okay, this is what GP. Specifically, this is infinite GP. This is infinite AGP. Okay. Now, 1 q power 0, 1 q. What is the formula for infinite GP? Do you remember? S infinity, which means sum of infinite terms, will be in a GP. Okay. It will be A by 1 minus R. What is A? A is the first term of the GP. R is the common ratio. Okay. Remember this formula. Okay. Now, if you apply that formula here, q power 0 is the first term. Okay. So you can write uh, q power 0, the first term, 1 minus, what is the r? R is nothing but q, common ratio, which is q. Okay. Now, s minus q power 0 is what? 1. Q power 0 is 1. So, s minus sq will be p into 1 by 1 minus q. Correct. Now you want to find s, right? So if you take s common here, s is equal to p into 1 by 1 minus q whole square, correct? Because your 1 minus q will be here. If you take as common, you bring that here, it will be 1 minus q whole square. Now what is 1 minus q? It is p, right? So p, 1 minus q is p, because p plus q is 1, right? So by this time you should know this, okay? By 1 minus q is p, so you get p square here. Now p and p get cancelled, so your s will be 1 by p. Understood? So what is the sum? What is the s we're trying to calculate? S is nothing but this summation, right? P into 1. What is this? Nothing but e of x. So what is the value of e of x? E of x, which means mean, is nothing but 1 by p. Okay? Mu is nothing but 1 by p. Understood? Simple. Okay? Now next we'll see the variance. What is the formula for variance? Remember, variance will be e of x square minus e of x the whole square. Correct? Now, so we have to find e of x square. Correct? What is e of x square? This will be sigma times x square f of x. Now, I'm tell you before solving this, you can try, okay, because same procedure as we did in the for as we calculated for me, but whatever you're doing the multiplication of q, the common ratio, and subtracting, you will do the two times. Okay, we'll see. So this will be from 1 to infinity. Okay, not writing it again and again. So x square, what is f of x? It will be q power x minus 1 into p. So when you open this, you will get 1 square q power 0 times p plus 2 square q power 1 times p plus 3 square q power, sorry, 3 square q power 2 times p. Correct. Next will be next term will be 4 square q cube. Okay. Now previous series we had this as agp, but this is not agp. Okay, because this is 1 square, 2 square, 3 square. This is sum of n squares, but it is attached with a gp, q power 0 p, q power 1 p is gp. So we have to see some techniques. This way I told formulas will not work out always. Okay, because every time you use a formula, you will not know how to proceed with the problem when the formula is not directly applicable. That is a problem. Okay, this goes on till infinity. Okay, now imagine this, let's say the series to be s. Okay, so this will be 1 square q power 0 p plus 2 square q power 1 p plus 3 square q power 2 p, so on up to infinity. Okay. Now, when you do the same thing, just to do sq, okay, which means you're multiplying this common ratio q with this series, okay, you will get uh, 1 square q power 0. This will be 1 square q power 1p. Similarly, I'm writing this in order for the convenience through subtract, okay, plus 2 square q square p, and so on up to infinity, okay. So now you subtract these two equations. Okay. Now if you subtract, what will you get? S minus SQ is equal to, this will be what? This will be 1 square q power 0 p plus, you subtract 2 square q power 1 p and 1 square q power 1 p. So what will you get? I'm not taking p common here. Okay. I mean, you can take it common, but I just forgot to take, so you can just proceed with that. Okay. So if you do q power 1p in every term, if you see, apart from the square terms, everything is common, no? So you can, that will come outside anyways. 2 square minus 1 square. What is what is a square minus b square? 9, 8, 7 standard max. A square minus b square is a plus b into a minus b. So it will be 2 square minus 1 square, which is nothing but 2 plus 1 into 2 minus 1. So this will be 2 plus 1 into 2 minus 1. Understood? So if you apply this concept of a square minus b square, your this term will always be 1. Correct? If you want, you can check the next term. 3 square minus 2 square. It will be 3 plus 2 into 3 minus 2. Similarly, 4 square and 3 square. 4 plus 3 into 4 minus 3. Every time you do the multiply, the second term of the expression will be 1. Okay, which means you will always get to add 2 and 1, 3 and 2, like that. Okay, so when you add 2 and 1, what will you get? 2 plus 1 is 3. 3 q power 1 p. Similarly, if you add 3 plus 2, what will you get? 5 q square p, and so on up to infinity. Okay, now this one you got. Now again, what I'm doing now again when you see this series, okay, now you get an AP here. See, so this will be 1, 3, 5, 7. This is an AP with common difference 2. It's starting term is 1. And again q power 0, q power 1 is a GP. Okay, now what I'm doing again, multiplying this with q. So this will be SQ minus SQ square. Understood? When you multiply this with q, you get the same thing. Now this will be q power 1p. Because see, when you multiply this term with q, what will you get? Q power 1p plus, when you multiply again q, you will get 3 q square p, so on up to infinity. Okay, now the problem is solved, because when you subtract this again when you subtract this, okay, this will be, carefully to subtract. Okay, SQ minus SQ square. When you multiply, sorry, you're subtracting first equation, then sorry, you're subtracting second from first, right? Sorry, s minus sq, which means second from first. Correct. So again you have to subtract second from first. Okay, which means s minus sq minus sq. Again, if you do minus, it will be plus. It's just simple maths only. Okay, sq square. When you subtract this, you will get q power 0 p, plus when you subtract 3q power 1p minus q power 1p, you will get 2q power 1p. Now again you will get 5 minus 3, again 2q square p. Now again next term will be what? 2q cube p. If you want, you can try. Okay, so on up to infinity. Now, when you take this, leave this part, take only here this part alone. Okay, when you take 2 common out of here, you will get qp plus q square p plus q cube p, and so on to infinity. Isn't this an infinite GP? Yes, it is. So you will get 2 p. If you take common outside, it will be q plus q square, and so on. What is the sum of infinite GP? I just told in the calculation of mean. It will be a by 1 minus r. What is a? A will be q. That is the first term, minus 1 by by 1 minus q again, because given the common difference is 1 minus q. Sorry, q. Now do not forget this q power 0 p. Q power 0 is 1. Okay, just write 1. P plus p plus. Okay. Now what is when you see this, your p is nothing but 1 minus q, right? So this will get cancelled. This will get cancelled. Okay, so you are left with p plus 2q. Correct. Now bring this down here and write. So this will be, if you take s as common, you'll get 1 minus 2q plus q square. So this will be p plus 2q. Just you can do this as s into, this is nothing but 1 minus q the whole square, right? So if you open this, you'll get 1 square, just 1 plus q square minus 2q. Okay, and this will be, write p as 1 minus q. So 1 minus q plus 2q will be 1 plus q. Correct. Now what will be your s? Your s will be 1 plus q divided by 1 minus q the whole square. 1 minus q is p, right? So p square. But remember, okay, this is not the final variance. This is nothing but the e of x square part, right? E of x square only we have found. This is the whatever we have found now is the value of e of x square. So now do uh, variance is equal to e of x square, which is nothing but 1 plus q by p square. Okay, minus mu square is what? Which is e of x the whole square. What was mu? 1 by p, right? So 1 by p square. So this will be 1 by p square. Now if you do 1 and 1 will get cancelled. Finally you get q by p square. Okay, so this is the variance formula. Okay, variance nothing but, or you can write 1 minus p by p square, because q can be written as 1 by p. Those things you can see yourself. So what we have discussed today in this geometric distribution, when you do, when you keep trying until you succeed, then that situation can be formulated into geometric distribution, where we took an example of archery. In case of archery, you keep trying until you get a failure. So let's say the probability of you hitting the bullseye is, let's say, zero point 0.5, something like that. You keep trying but you don't hit the bullseye, so the failure probability is point okay, let's say the success probability is zero point 0.4. Okay, the failure probability is zero point 0.6. So if you try 10 times, your zero point 0.6 times your zero point 0.6 times, sorry, zero point 0.6 is the failure probability. So that will come as zero point 0.6 bar 10 minus 1 is 9, and finally the success probability is zero point 0.4, because you are succeeding at last. Okay, but only catch is you will not know the number of tries before you start. Okay, unless unlike a binomial distribution. Okay, so that's what we saw in this binomial distribution. Then we formulated the PMF using the sentence we told in English, and then we found mu, mean, where we used the concept of infinite AGP, and similarly we calculated variance also using infinite AGP concept. Only thing is we did this concept of multiplying the common ratio and subtracting 2 times. Okay, so then I finally got uh, q by p square. Okay, I think a little bit pen was lagging, but anyways, I think it was fine. So thank you guys. Next we'll see one important property of geometric distribution before moving on to the problems, which is nothing but a memoryless property. Okay, we'll come there next. So until that, you keep revising. Thank you guys, bye.